In today's class, we'll be talking about fundamental principle of electronic switching. We'll be looking at switches. When we talk about switching, we cannot but talk about switching. And switching are majorly done using switches. And as you can see on the screen, there are different types of switches. The rocket switch, the soft press switch, we have the network switch, we have electronic switch, as you can see. Now on the screen, if you look at this type of switch, you can see this as what? They are our electronic switches. These are our rocket switches, press switch, we have toggle switch, so on and so forth. And I know many of us have come across things like this. They are network switches, also serve as switching, but we'll be concentrating much on these electronic switching because without these activities, many development boards things we do will not really serve the purpose it's supposed to. Now, this practical class introduction will go by exposing us to these fundamentals. Now, the fundamentals that will be exposing us to what is electronic switching. As you can see, it's just controlling a routine electrical signal, controlling current, voltage, using components, electronics component to establish, to maintain, to control the activity, switching on, off, fast, slow, low activities in. And in this era we are that is need for development of activities in electronics, your automation system, your control system, robots control, motor control, movement of most virtually all electronics components make use of switches, which switch between some terminals or connections, which are done to majorly we have 0 and 1 in most of our logic controls, which in many of the microcontrollers we still have the output 0 and 1. Now, the key components that is required, switch, as I've said earlier, is just to open and close circuit. And in electronics switching, majorly we have the transistors, the relay, we have the diode, we have the control signals, input signals that determine the states of such and the load you want to carry. This aspect of switching, load, is one of the major things, attributes we must first consider. The load you are carrying will determine the type of electronic switching that you will adopt and the purpose of the switching. Maybe you are switching using voltage control. In the course of this class, we will dwell more about. Now, what are the fundamental switching mechanism? We have different types of switching mechanism. If we talk about relays, we have different types of relay. Those are mechanical switching, physical movement of switch. Once its relay is powered, it moves from normally close to normally close, from normally open, vice versa. It all depends on the power. Normally close will be active and Once you switch it on, it goes to normally open. So it all depends on what you want to use it. Using understanding of switching will make it easy to develop electronics circuits or boards that you can use to adapt into your daily activities or development. We have solid state switching. These parts involve no movement. We have the use of transistors, MOSFETs, any related FETs. We have solid state relay also, which all this works with the principle of no movement. You will not see a physical movement, not like the mechanical switching. Those most mechanical switching, we still attribute them as electronic switching because it also requires electronics feed or voltage or current to activate them. Now, under this fundamental, on state allow current to flow, maybe small resistance. Off state block flow of current, maybe high resistance. All these things are also switches limiting, blocking, switching on and off. And the speed also, we can also use electronic switching to control speed. Power handling, the amount of power a switch can manage without damage. Like I said earlier, we need to know the load we are trying to control to determine the type of electronic switching. Those are one of the key things we need to consider in selecting our electronics switching. Now, I will dwell much on the bipolar junction and the FETs, that is the feed effect transistor. They are commonly used in many electronics control devices. You can control your motor, you're connecting to Arduino, connecting to microcontroller, you're connecting to any ICs. You is majorly switching. Diode is also a switching that allow flow of current in one direction. Though we have thyristors, we have thermistors, we have relay, as I said earlier. These are electromechanical switching control, which also still use electrical signal to switch on and to allow the movement from maybe normally closed to switch to normally. This bipolar junction transistor. Many of us have been seeing this. Many of us has been seeing this in many of our components. This device, we have been seeing them. What it does is to switch. And what are the advantages of this? They require current to flow through the base. Once you apply current here, the current will flow through and not allow whatever voltage that is here to now flow through to the collector. So we have the base as trigger. It now depends on the type or the configuration you are using. Maybe it's normally open or normally closed. We majorly use this process as a switching agent, and this one is NPN. The base is negative charge, which will allow positive flow here, while the NPN allows positive charge to trigger and allow, as they've taught you guys in your electronics classes. Now, it requires low input impedance. You can use it to amplification and switching also, but it also has its limitation. Like I said, in any switch, electronic switching you'll be adopting in anything, please always consider the load. The load can attribute to the temperature, can trigger the temperature, and most of these electronic switching devices are sensitive to temperature. Now we quickly move to feed effect transistor. Many of us have these. Are majorly voltage control device. In some instances, you want a particular amount of voltage and a feed eye of current before there is a trigger. Majorly, we have FET. I call it FET. It's being called FET now. Feed effect transistor. Now these transistors are being controlled. They control current through an electric feed. We have two types. We have JFETs and MOSFET. Many of us will have come across many components having this and some components having this. Many of us have seen inverters, many of us have seen amplifiers, and we come across things like this. They are very sensitive. Once they see a flow of current through, while if you look at it, they look similar to the initial transistor I showed, but this, if you can look at this now, you see heat sink. This is an heat sink. You can see an heat sink here. So this heat sink allows it to have a better thermal stability. At least, even if you're having much more, you can carry much load and high input impedance. You can regulate what enters. Now this one does not use base, emitter and collector, though they still work in the same principle, but that one is controlled by voltage while this is controlled by current. Now these use what we call the gate. Does similar things like base. We have the drain, we have the source and the drain, as we have the emitter and collector. So they work in that principle. During the practical class, we show you this and how to properly identify it with your multimeter or checking of a data sheet. Now, what are the key difference between the two, the FET and the BJT transistors? If you can look at it now, they are control mechanism. One is controlled, one controls voltage, and one, the FET, controls current. Power consumption, their power consumption are not the same. Noise characteristics. Many MOSFETs, we have a lot of MOSFETs that can be triggered by putting it in your finger, and it will trigger, can even damage some. We get some MOSFETs that are very FETs products that are very sensitive to any touch. The input impedance also vary, temperature and circuit applications. There are some applications that you cannot swap them. A device that you are controlling voltage is different from a device whereby you are controlling current. So those are the key difference. We show you some of these samples in the practical class. Please ask. Don't forget to ask. Now, what are the advantages of using electronic switching? They are fast in switching. Their switching speed is very high. For example, you design an electronic switching to do changing over process. In some instance, when you use mechanical switching device, before you toggle changeover switch mechanically, manually, you discover, you see the changes. And that is why many of us, if you observe inverters, once inverter change from the supply and to inverting process, that's microseconds change. It's not being observed. It's it's not easy to observe because it's in microseconds, and our brain, our eyes cannot easily picture it. Maybe most of us that are used to it, we just observe it through sense. So low power consumptions, they don't consume much power, no mechanical wear. By the time you start tugging your changeover switch over and over, with time it will wear off, it burns, high heat that occurs in most of those ones. But by the time you've calculated your load and you put it into consideration, and electronic switchings are small, can you imagine how big 100 amps changeover switch, all these knife edges are big? But with your solid state relay, very small solid state relay that we are going to still show you in the class, can be set to also do the same work. We have, and the maintenance, sometimes is maintenance free. It's also reduce interference. Many of our mechanical torque switch changeover, once you do the changing over, it definitely generates some electromagnetic field which interferes, especially if you're having a display devices. It interferes most time and it affects it. Now, what are these electronics switching can be used for in real life application? You use it to drive relay. You cannot just control your relay directly, and these relay are majorly used to convert your low signal or low voltage. Many of our microcontroller cannot use more than 5 to 12 volts, maybe 3 to 12 volts, many, most, let me say that. In real world application, we control motors. Your robots, many of your robots still work with using motors, light display, LED, power management, relay drives, stepper motor, movement, all those things. We still need an electronic switching device to switch so that it can transfer that switching to a bigger device that can accommodate to contactors, bigger contactors, relays that can now be attached to a bigger devices. You want to use your microcontroller sensors attached to it to control your street lights, your house lights, your movement, security devices in the house. Most of these your microcontroller works, but your output volts maybe is on 250 volts. So you still need this electronic switching, and that is why we are trying to introduce you guys, trying to introduce people to it, to understand the basic rudiment so that you can easily apply it to your projects, to a development and all that. We cannot but talk about other switches other than electronic switches, because in as much you are using an electronic switch, you still need adaptation or addition other switch. Let me come again. No matter how you use an electronic switch, you still need some other switch in order to serve as let me say safety device. And in any circuit we build, please let us always consider the safety part or emergency buttons, let me put it that way. So as we can see, we have the toggling switch, push button, limit switch, the read switch and the relay modules. We will see all this in the practical class. Physically you touch, you will run it, and you see how it works. Now let me move forward. Let me lay more emphasis on the torque switch. When it comes to torque switch, they are very common pole switch. We see it in our day-to-day activities, day-to-day programs. We used to at least come across it. I got this from this Greek hub. Many of us can see this. We have the single pole, single throw. You just tug once, on and off. And we have single pole and double throw. You discover that it has three poles. You understand? You can see this, you can see this one, you can see this two, you can see the third one. Now definitely these middle will be your common, so this one give load to, and when this one give, so once this is tugged this way, it connects, that's we connect this together, so that is how all these things work. Connects this together, and once you talk to the other side, it connects this together. So that is how these things work, and we have different type of it. We have different, if you can look at this one is double pole. You can see the double pole. Look at this 1 2 3 4 5 6, and in many of our multimeters you see this there. They are always double pole, double throw, but in most cases they are press switch, not toggle switch. So all these things are other switches that we must at least add to our design to still provide a safety medium to our electronic switching process. Now for the class, please take note of this. We provide all these devices for your practical class. The resistor, we have them, you ask for it when you come individually. The capacitor, transistors, breadboard, and the tasks you are going to do individually will be given to you. Please take note. So as an engineer, there is one fundamental thing that we also consider in everything we do, as in troubleshooting things or the component or process. Not that for us to just develop or just design devices, we must familiarize ourselves with the common issues that come up with electronic switching. That is why you see when people design, develop or components or board circuits projects, you discover that on project defense day we have a lot of issues, and this one stop working, this one stop working. Majorly are the switching devices. Now the common issue are not switch not operating, commonly due to soldering process of the switches. Even most of the torque switch, when you are soldering it and you are not using the soldering properly or in a right manner, damage it easily. So as a result of overheating that occurs in the process of trying to fix or to assemble or to solder connecting wire or jumping wire to the switches. So these things occur majorly. So that is one of the reasons I used to encourage you guys, learn how to solder, the soldering principle, understand it very well. If you don't know it, I have a video for that. If you subscribe on my channel, you should be able to have access, or if you don't have access to it, you can drop ask in the comment section and I will give you a link to that. Now, slow response. There are some instances that you expect a switching to occur at a particular time, especially control system that involve timing, and you now discover because of a particular load, a timing that's supposed to occur at maybe every 1 minute is not happening at every 1 minute, 20 seconds, 10 seconds. So all these common problems are attributed are common things that happens in electronic switching, based as a result of calculation, as a result of some other factor, voltage drop, the capacitor you are using, you are not using the right amount UF, you are not using, these small minor calculations sometimes used to affect a majority of us doing design, development of boards, development of circuits. Most time we just see some circuits online, we try to modify it to suit our own. There are rudiments, there are calculations required. And voltage drop, sometimes we load our circuits, you now discover that after you apply load, there is change in temperature. So sometimes some of these are inevitable, but it must not be obvious. So solution to some of these the checks that we are required to do once we design our product development in electronics. Now, you perform analysis. A lot of analysis can be performed even by just observing the change in the physical appearance, temperature, if there is any smell, you understand. Data collection, you must collect data. When you apply load, what is the voltage, what is the current? When there is no load, what is voltage, what is the current? You now analyze those data collected to be able to know what and what should I do, which threshold should I not exceed. Switching time measurement, like I told you, we must be able to measure accurately. It must give us what we want. Efficiency in calculation, temperature monitoring is very key, very key, and that is why many electronic switching device have their own temperature range, which once they exceed that, there will be no switching. Load response also. So rating is very important in anything we are doing. So with this, we'll be going to the practical class, and in the practical class we will see each of these components. Each and every one of us will test how it works. Dependently, you did develop a switch device, and we give you other electronics switching device. You do using maybe a rocket switch, a toggle switch, or a press switch to do, and at the same time you still do using an electronics device. If time permits, we can go as far as using sensors to also serve as triggers, so that we can have that elementary basic knowledge about it. So thanks for your time. We meet in the practical class, but mind you, take note of the time at which you study this lecture, because details question will be asked that will permit you for the practical class. So just to make things easy is why we are going this method. And the comment section, your serial number, not your matric number, the serial number given and your group should be written, and the time in the comment section. Thank you for your time. Please don't download, please. Thank you, and let's meet in the practical class. We'll be waiting for you in the practical class. So understand this very well. There are a lot of points and things written that you must go through. We ask to allow you access to the practical class. The number is much, and we are trying to make you guys understand better. That's why we are going this way. Thank you for your time.